Hello everyone, welcome you all. So in this video we are going to discuss about rectifiers. So as we know, a rectifier is an element or circuit which converts AC supply into DC supply. So there are two types in rectifiers, half wave rectifier and full wave rectifier. So half wave rectifier means it will only convert a half cycle into positive cycle, and a full wave rectifier means it will convert both the positive and negative cycles into a pulsating DC. So now today we will discuss about half wave rectifier, and in my next video I will be discussing about full wave rectifier. So if you are new to the channel, guys, please subscribe the channel and hit the bell icon for more updates. Now coming to rectifiers. So a rectifier is a device which converts AC voltage to pulsating DC voltage using one or more PN junction diodes. So it will convert AC to DC using diodes, and the PN junction diode conducts only in one direction. It conducts when forward biased, while practically it does not conduct when reverse biased. So a PN junction diode is assumed to conduct in only one direction as it is forward biased. So positive is connected to the P side and negative is connected to the N side. So it is assumed that practically when the diode is reverse biased, then it will be not conducting. But in a real scenario it will be conducting, but that is of very small current, so it is assumed to be a zero current. So that's why it can be assumed as a turned off situation when it is reverse biased. So the PN junction diode subjected to an AC voltage acts as a rectifier, converting alternating voltage to a pulsating DC voltage. So when as the diode is conducting when only it is forward biased, it can be used to rectify the AC voltage into DC. So now coming to a half wave rectifier. This rectifier circuit consists of resistive load rectifying element, that is PN junction diode, and the source of AC voltage, all connected in series. So all these components are connected in series. So to obtain the DC voltage across the load, the AC voltage is amplified to rectifier circuit using a suitable step up or step down transformer. So if you want the voltage to be more, then you can use the transformer, that is step up, and if you want to decrease the voltage across the load, then you can use the transformer which is step down. So it will decrease the voltage from primary to secondary. Mostly a step down transformer with necessary turns ratio is used. So the input voltage is given by Es equal to Em sin omega t, where pi omega is 2 pi f and f is the frequency of the input. Now the transformer decreases the peak value of the secondary voltage if N1 are the primary number of turns and N2 are the secondary number of turns, and EPM is the peak value of the primary voltage. Then the primary voltage, secondary voltage can be found out by knowing the secondary turns ratio, primary turns ratio, and primary voltage. So if you know these three terms, then you can find out the secondary voltage. So depending on the primary and secondary voltage, you can decide the turns ratio here. So the peak value of the load current is given by Im equal to ESM divided by Rf plus RL plus Rs, where Rs is the resistance of secondary winding of the transformer. So the circuit diagram for the half wave rectifier is something like this. AC, single phase AC supply is given at the input. So this is the step down transformer where the primary turns ratios are more and the secondary turns ratios are less. So input to the transformer is the AC voltage. Then here is the AC voltage appearing across the diode. So when there is a positive half cycle, means this side is positive and this side is negative. For negative half cycle, this will be negative and this will be positive. During the positive half cycle, the diode will be forward biased and it will conduct. So this is the waveform. Then during positive half cycle, the diode will conduct. During negative half cycle, the diode gets reverse biased and it will not conduct. So for this there will be no output. Again for the positive half cycle, the diode will again conduct because it will be forward biased. And for now coming to the output waveforms of the rectifier circuit, that is half wave rectifier. So this is the input signal voltage. So it is a continuous AC supply which is given to the primary of a transformer. So along x-axis time is there and along y-axis the amplitude of the input cycle is taken. So during positive half cycle, the diode will be on. So for this positive half cycle, the diode conducts and the output is present. So during negative half cycle, the diode gets turned off because it is reverse biased and there is no output for the negative half cycle, and then for again positive half cycle the diode conducts, and for negative half cycle the diode will not conduct, and again for positive half cycle the diode will conduct. So like this we will be getting the output DC pulse when input is only for a positive half cycle of the input, and for negative half cycle we will be not having any output. So this is why it is called half wave rectifier. So it will rectify only the half part of the wave, that is positive half cycle of the wave. So in case of full wave rectifier, the negative half cycle will also be get rectified, and we will be getting a continuous DC pulse, because there will be using two diodes which are connected to at the secondary of the transformer. So they will be conducting for positive as well as negative half cycles. So that concept we will be discussing while discussing the full wave rectifier. So now coming to some of the advantages and disadvantages of half wave rectifier. So advantages are only one diode is sufficient. So this requires only one diode. The current circuit is easy to design and analyze. As only one diode is required, the circuit is very easy and designed to as well as analyze. No center tap on the transformer is necessary. So in case of full wave rectifier we require a center tap, but in case of half wave rectifier we don't want any center tap on the secondary of a transformer. So the complexity of the circuit is very low. But the disadvantages are the ripple factor of a half wave rectifier circuit is 1.21, which is quite high. So as the ripple factor increases, the efficiency of the circuit decrease. So the ripple factor should be as less as possible. So for half wave rectifier the ripple factor is 1.21, which is very great as compared to the full wave rectifier, which is having 0.93 as its ripple factor. Now coming to second point, the maximum theoretical rectification efficiency is found to be 40%. So out of 100 the efficiency is 40, means only out of 100 cycles only 40 cycles are get rectified. So this is a very poor representation of efficiency which cannot be tolerated. So in practical situations the half wave rectifier can't be used in the real life. So third point is the DC current is flowing through the secondary winding of the transformer, which may cause the DC saturation of the core of the transformer. To minimize the saturation, transformer size have to be increased accordingly. This increases the cost. So the problem of DC saturation, that is transformer saturation, happens here. To avoid that one, the size of the transformer has to be increased, or it should the size of the transformer should be big. So this will increase the cost of the overall circuit. Okay, so fourth one is the TUF is very low, showing that the transformer is not fully utilized. So the TUF factor is very low. So TUF indicates the transformer utilization factor. So the transformer utilization factor is very low, means the transformer is not get utilized properly. So these are the some of advantages and disadvantages of half wave rectifier. So if you like the video guys, hit the like button and subscribe the channel for more updates. Thank you. Thanks for watching.